In today's session, we are going to see about the machine learning concept. So what is machine learning, how we can learn the machine learning, and why we need to know about the machine learning concept, and what are all the applications of machine learning we are going to see. And then one of the machine learning type, we will see it in detail. And as usual, in the end, we will take one project and we will try to solve it. First, we will see what is machine learning. So machine learning is nothing but an subset of artificial intelligence. So in a bigger picture, if you want to see means machine learning will come under the artificial intelligence part. So we are having various AI based applications which we are using in our real time, right? So some of the AI based applications which we are using in real time are we can say chat GPT, which is trending nowadays. So it isn't text based, so it generates text for the input given by the user. Then, if you are aware of Lenscard website, so if anyone of you have used a Lenscard website, means there what it will do is it will scan your face, and using the augmented reality, it will give you the frames. So you can change the frames and you can able to see how it will look in your eyes, like the frame will look in your face. Like that we can able to analyze. Then in everyone's mobile phone, okay, either you will be having the Siri or you will be having the Google Assistant, right? So that is also one of the AI based application. So voice assistant, or we can have a Amazon Alexa is there. That also we can say it as one of the example. In Microsoft, if you take means we will have the Cortana, and then we will have a Microsoft Copilot, which will help you to generate code. Okay, so let us see the machine learning part. So simple definition, if I want to give for the machine learning is learn from the data and solves the problem. So there is a lot of real-time problems are there. So for that problem, what we will do is we will pass some previously collected data, we will pass into our machine to make the machine to understand the pattern. Once it has understood the pattern, it can able to predict for the new data which we are passing. So in this way, we can able to solve lot of real-time problem. And we are having three different types of machine learning is there. So these three are the basic types which we are having in the machine learning concept. So first type is supervised learning. So in supervised learning, we will pass the input data along with the label. So the data will be having their label as well. Example, here we are having the apple image and banana image, right? So this is apple, this is banana. Like that, we will give what data it is, like that along with the label, we will pass it to our model. So the model can easily able to understand the pattern. So once it has understood the pattern, then we will try to predict. Okay, we will pass some new value or new image to our model, and we will test whether it can able to predict it correctly or not, whether it can able to differentiate whether we have given the apple image or banana image or some other image. To understand this very simply, what we can say is, suppose a baby is there, okay, 3 4 years old baby is there, and you are planning to teach that particular baby. So how you will do? You will repeatedly show that particular object, or you will repeat the same word again and again and again, right? So what that baby will do, it will first start to observe, okay, what action the person is doing, okay, how he is pronouncing the words, or what action he is making, everything it will start observing in the beginning, then it will slowly start to repeat it. So initially, when you're trying to repeat it, what will happen? It will make some mistake. So whenever it is making, we will try to correct it. Okay, this is not it. We have to change it. The pronunciation, or for apple, it is showing banana means no. This is the not banana. This is apple. This is only banana. Like that, we will change it. We will correct it. Right. Similarly, here also, even when we are passing the data, input data, and then we are passing the along with the label, we will not get the expected accuracy in the first attempt itself. So we have to further work on the data. We have to do some tuning work and all will be there. For each algorithm, we will have different tuning types. Then we will attain some certain accuracy. And here what we will do is we have to pass huge data set. Okay. Since it is machine learning, we can able if 1,000 or 10,000 data records if we are having means it is more than enough to create a model. But if you are expecting more accuracy means the more data you are passing, the more pure data you are passing to your data model, accordingly you will get the expected output. Accuracy level also will be very high. Okay, more than 95, 98% accuracy is there means we can say okay, this is a good model. Supervised learning is further categorized into classification or regression based model. So when we say classification, the output will be in the form of classes. Okay, it will be like yes or no, this or that. Here in the example, apple or banana, like that we are having, right? So like that we will have some choice, and from that only it will choose the output. When we come to the regression part, we will be having the output in the form of real numbers. Okay, example what we can say is house price prediction, gold price prediction, Bitcoin prediction, stock prediction. Likewise, various predictions we are doing, and the output is going to be in the form of real number means, then those model we call it as regression based model. Okay. So for the classification based model, we are having algorithms like k nearest to neighbor algorithm is there, support vector mission algorithm is there, decision tree, random forest, navy bias, neural network, and then gradient descent methods are there. And in the regression part, again we are having separate algorithms like linear regression is there, logistic regression is there, and then polynomial regression is there. So these are all some of the algorithms we frequently use for the supervised learning. A real-time example, if I want to say for this supervised learning is, mm, so nowadays in the CCTV camera, it is detecting the faces and other things, right? Like in the CCTV camera, they will have that algorithm. So what that algorithm will do is it will detect whether the person is violating the traffic rules or not. Okay, if you are going in a bike means whether you are wearing the helmet or not, whether you are stopping in the red signal or you are crossing the red signal. If you are in the car, whether you are wearing the seat belt or not, and then whatever traffic rules is there, whether you are following it or you are violating it, so it will monitor. So whenever you are violating the traffic rules, immediately it will capture your face as well as your number plate. and in the database it will have the match for the number plate, whatever address it has been registered, it will send the fine amount to the registered mobile number, as well as you will get the fine in the registered post also. Right. So this we can say it as one of the example for supervised learning. So what they will do is they will train the machine with a lot of faces. Okay. People wearing helmet, people not wearing helmet. Okay. Whether they are going in over speed, whether they are wearing the seat belt or not wearing the seat belt, like that all type of images they will feed along with the label. Okay, this is an helmet wearing person image, this is not helmet wearing person image, seat belt wearing person image, like that they will pass images, and they will train the model accordingly. The second type we are having is unsupervised learning. So in this unsupervised learning, we will pass the input data without the label. So without the label, if you are passing, means how our model will understand is. So it will first initially it will take one data, and it will try to understand the pattern of that particular data. Then it will take another data, and it will try to compare it with the previous data. So if any match is there in those data, means it will group them as cluster. Okay, the process of grouping we call it as cluster. So in this example, we can able to see. I haven't given it in order, like apple image also is there, banana image also is there. Like that mixedly I have given. But in the output, if you see, means it can able to group apple images separately and then banana images separately. But our model doesn't know this is apple image, this is banana image, like that. Our model doesn't know. It will simply segregate. Okay, these are all in similar pattern and these are all in the similar pattern. Like that, it will create a lot of clusters. So for this, again, if I want to say one example, means again, small baby is there. Okay, you are not saying that baby, okay, what shape it is, everything you are not saying. Simply you are giving that particular baby with a lot of, toys. Okay, toys is there in different shapes is there. Okay, circle shape, square shape, triangle shape, like that in different shapes you are having some toys. And you are giving empty basket to that baby, and you are asking to, segregate. Then what that baby will do is just it will take one object, it will see, okay, it is in round shape or anything. Okay, it will put it in one box. Again, it will take another one object, and it will check, okay, whether it is having the same shape or color or anything. If it is different shape, means it will put it in different basket. So like that, we can train our model. Okay, suppose I'm having plate images. Okay, I'm passing some plate images, and then spoon images, and then fork image to my model. Okay. So how many cluster do you think it will create? If I'm passing three different data. Okay. Plate images we can take, and then spoon images I'm passing to my model, and then fork image I'm passing to my model. How many cluster it can create? So it will actually create only two cluster. As a human, we know that okay, spoon image just different and then fork image is different. But as per the mission, okay, there is 90 percentage similarity between a spoon image and the fork image, right? Only the head portion is going to change. In the spoon, the head portion will be like in oval shape, and in the fork, it will be in like that spikes will be there. So there is very less possibility that it is directing. Okay, it can direct the fork image also as a spoon image. Okay, it doesn't know the name, it doesn't know the label those images. Simply it will categorize. Okay, plate image and all one group. Uh, Fork and a spoon image and all another group. Like that, it will segregate. Okay, so why it is easily detecting the plate image separately means completely the shape, size is not going to match with either the spoon or fork, right? So that is why it is creating it as a separate group. So same concept you can apply it in different places. If you are passing, you know, a bird image, okay, cat image and dog image, and then fish images like that. If you are passing means bird, it will have different features. Okay, so it will create a separate group. And similarly, fish also the structure, everything is going to be different. So it will create a different group. But when it comes to dog and cat, okay, again the similarities are going to be more. Okay, sometimes some cat look like dog and some dog look like cat. If you have taken a puppy image, means more or less look same. So there is more possibility that it will group a dog image and cat image as a single cluster. Okay, or it can mix match even if it is creating a separate group, a dog images separate group, cat images separate group. There is some possibility that in the cat images some dog image will be there. Similarly, in dog it can have some cat image. There is possibilities are there. So these type of prediction we call it as unsupervised learning. So in unsupervised learning, we are having clustering and then association method. So for clustering, we will use algorithms like principal compound analysis, hierarchical clustering, singular value decomposition, independent component analysis, and then k-means clustering we will use. So where we will use this association method is, if I want to again, I don't know the exact result, I just want to predict it. Mostly used data set for this association method is supermarket data set. Okay, so I will explain you in simple terms. Suppose one supermarket is there. Okay, so in that supermarket, you can find A to Z products, and many customer will come and go, and they will buy different number of products. Okay, one customer can buy 10 products, another customer can buy two products, like that they can buy. So what we have to do is we have to perform some analysis, okay, to increase the profit. What is the most frequently bought products in our market, supermarket, like that I want to analyze. So for that, what I'm doing is I'm taking some frequently accessed items from my supermarket, and I will take some person and how they are buying the products. So those details we will see. So I'm taking products like okay, bread, butter, jam, milk, egg. Okay, 5 items I have taken, and I'm just labeling it as like I1, I2, I3, I4, I5. Okay, these are all the items. Then I'm taking person one. Okay, person one. What are all the product or the item he is purchasing? Just for our assumption, the first person is buying the bread, okay, butter and jam. Then the person two, what he is doing is he is buying the bread, egg, milk. Okay, milk also is purchasing. Person three, I am taking. So person three, what he is doing is buying bread, jam, and then milk. So like this, as many persons I want, I can able to create. So it is not necessary that everyone has to buy three product. So some can buy more product also. Okay, to increase that. In person one, I can even add. Okay, he is purchasing egg also. So like that I have created. Then what I will do is I will try to compare each and every person with another person. Okay, and I will try to find the common items they have purchased. If I am comparing person 1 and person 2, what are all the common items they have purchased? So they have purchased the bread and then egg. Okay, item 1 and item 5 they have purchased. Then when I am comparing person 1 with person 3, then bread is common. That item 1, item 3 is common. Then if I am comparing person 2 with person 3, then again bread and milk is common in this scenario. So likewise, I will start, creating groups. Okay, person 1, person 2 means bread and egg. Person 1 and person 3 means bread and jam. Person 2 and person 3 means bread and then egg. So like this, I will create group. Then what I will do is I will perform some analysis. So from the analysis, what I will find is before performing the analysis, where these products are placed. Okay, in the supermarket, there is high possibility that one product will be placed in one location and another product will be placed in some other location. Okay, so it will be difficult for the customer to, find each and every product from different location. If it is a big supermarket, means they cannot spend lot of time in finding the product. So if they are taking more time, means they may, leave some of the product in their list. So to avoid that, as well as to make the customer to buy more product. So what we can do is we can arrange all the frequently accessed products. So whenever the person is purchasing bread, because bread is common in all three person. So we will place the bread in one rack. Okay. In near to that particular bread, we will keep all the other products which we are frequently purchasing. So near to the bread, we will keep the butter, jam, egg. Okay, if we want means we can keep the milk also. So what will happen if the person is coming to buy only the bread and if he is seeing other products also near to that, immediately there is more chances that the person can buy other product also. So it will save their time as well as increase our profit also. Okay, even if we are not in the plan, okay, the customer is not in the plan of buying other products. The moment he see that product, he may get some idea. Okay, bread we have purchased. Okay, if I purchase egg means I can put some bread omelette and I can eat. Okay, or if he's thinking, okay, I am already having egg in my house. Then he can choose jam. Okay, jam bottle is going to get over. I can purchase one jam. And another strategy also the market people can do. What they can do is they can give some offer. Okay, they can mention like okay 40% off, 50% off like that. They are putting means even they don't need the product. Just because the offer is there, they will try to purchase the product. Okay, by default, a jam bottle price is 100 rupees. For in an offer, you are giving it for 60 rupees. Immediately, they will think, okay, we are getting 40% profit. So they will buy some product. So in this way, indirectly we can increase the sales. So if the sales is increasing, automatically the profit also will get increased. Right. So for this purpose and all this unsupervised learning, this association concept will be very helpful. Okay. Then the third method we are having is reinforcement learning. So in supervised learning, we have provided both input and output to our model. And in unsupervised learning, we will provide only the input and we will not say what is the output. Simply, it will create clusters. In the reinforcement learning, we will pass some set of rules and instructions, everything we will pass, but we will not provide any prior data to our model. Instead, it will learn by making some action and by observing the environment. So every time it makes some action, it will either get reward or it will get punishment. So whenever it makes the correct move, it will get the reward. And whenever it makes the wrong move, it will get the punishment. Okay. Based on that, it will start learning. So next time if the same or the similar kind of scenario is coming into the picture, it will change the decision until it comes to the correct decision. So here you can able to see one maze is given and then one rat. Okay, how the rat will work. And it has to find the food. Food is placed in one particular location. So what it will do is it will first travel in the maze. So every time it makes the wrong move, it will remember, okay, in this place, nothing is there. And it will come back and again it will check in other location. So until it finds its food or the way to go out. So it will be inside the maze itself, right? Similarly, our model also, suppose in one side we are having fire, on the another side we are having water, and we have trained the model. So first it is going and touching the fire part. So it will get hurt. Just for our assumption, it will get hurt. So it will get some negative points. So it will remember, okay, whenever we go near the fire, it is a danger. We should not go and touch that. Like that, it will store it in the memory. Then it will go near the water and it will touch it. When it touching the water, nothing happens to it. Okay, it will take it as award. Okay, some reward it will get, so it will store it in the memory. Okay, so whenever we go near to the water, it is safe and we will not get any danger. Like that, it will store. So next time it sees the fire means it will try to avoid it instead of touching. So there is one real-time example is there for this reinforcement learning. So reinforcement learning, we can say that automated cars is one of the example for the reinforcement learning, because every fraction of second it has to make some decision based on lot of scenarios around the environment. For example, one automated car is traveling in the highway road. Okay, some signal is there. So it has to see what color signal is there. If it is green only, it has to go. And it is going in 80 kilometers speed. Okay. Suddenly one car is taking overtake that automated car. Then suddenly it has to put either brake or it has to slow down or it has to change the lane. If it is changing the lane means it has to put the indication. Okay. Whether left or right, that has to be indicated. Suddenly, green signal turn to red signal means it should know, okay, we have to slow down, we have to click on the brake. So every possible scenarios, it should able to analyze and it has to take the decision time to time. Okay, decision is not going to be same every time. So this and all comes under the example of reinforcement learning. And there is one mission is there, okay, which can able to play Go game. Okay, like chess game, there is one Go game is there. So what happened is they have given all the instruction how to play the game, rules and regulation, everything they have fed it to the machine, and they made the machine to play with the champion. Okay, they conducted 3 rounds, 3 rounds of game they have conducted. And what happened is in the first round, champion won. Okay, champion won the game and the machine lost. So in that game itself, what it has done is it has started learning the moves. Okay, what move the machine has made, for that what move the champion has made. Okay, where and all the machine has made the mistake. Okay, why it has lost the game. Everything it has analyzed in the first game itself. Then what happened is, in the remaining two games, since it has learned from the champion, next to two games, the machine only won the game, not the champion. So like this, it will learn from its failure. Okay, learn from its mistakes and it will correct it the next time. So these type of learning we call it as reinforcement learning. So there are three different ways we can implement this reinforcement learning. It can be a model based, or it can be a policy based, or it can be a value based. And in the model based, again, we are having two algorithms like Q learning, or we can use the Markov decision process. Next, we are going to see how we can learn this machine learning concept. First, in the programming part, you should know either the R programming language or you should know the Python programming language. So R is also an equal competitor for the Python programming, but Python is mostly used because of its versatile feature. Okay, if you are knowing the Python language means we can use it for web development, we can use it for AI, ML. So lot of places we can use this Python programming. So that is why most of them are preferring the Python programming language. But if you are learning the R programming language means that will be an added benefit for you as well. Okay, because our programming is specifically designed for data analytics and then for the machine learning concept. Then what are all the basic skills that you should know in the mathematics concept to learn the machine learning is, okay, you should know about the linear algebra, calculus, probability. And when we come to the statistics part, you should know about the mean, variance, inferential statistics, IQR, probability, descriptive statistics, regression, correlation, hypothesis testing, normal distribution, range, A/B testing, mode, maximum likelihood, and then standard deviation. So there are a lot more also is there, but these are all some of the basic mathematical concepts you should know if you are learning the machine learning concept. Then the database part. So in the database, we should know we are having the structure oriented database is there and unstructured oriented database is there. For the structured, we are having the MySQL, and then for the unstructured, we are having the MongoDB. There are a lot more databases are also available, but very famous and frequently used is MySQL and MongoDB, because all the data which we are going to use it for the training purpose has to be stored in one particular database. So we should know some basic query language to store the data, to access the data, to filter the data, to modify the data, to delete the data. So some of the basic concepts we should know in the database part. Suppose if you are from a non-programming background and you are not very strong at any of the programming language, still you are planning to start your career in the machine learning. So is there any tools to learn machine learning? Is yes, it is available. We can learn, either you can learn Power BI, Tableau, ClickSense. Okay, like that, various tools are also available. Business analytics tools are there. Here, you don't need to know much programming language. If you are knowing the basics, means it's more than enough, because these tools more are like look like a Excel. Okay, advanced Excel like that it will be, and you just have to drag and drop all the features to create a chart, graph. or you can even create a dashboard also just by the drag and drop method. And in Power BI and all, we can able to convert the output into a Python code also. So that features also available in the Power BI. So some limited access only you will get it for a free version. And if you want to explore the complete features of Power BI or Tableau means you have to have a premium version. So this tools will be an best alternative if you are not strong in the programming language. So this also will be an added benefit if you are knowing these tools. Then steps. We are having 7 basic steps in our machine learning concept. So these 7 basic steps you can see it in any project. So any project if you take means you can able to see these 7 steps. So first is gathering the data. So we have to gather the data in any form. Okay, it can be in a CSV format, or it can be in Excel format, or it can be in JSON, XML, like that. Various different formats are there. You can gather the data in any of your format. Then data preparation. So in the data preparation part only, what we will do is we will clean the data. We will remove the unwanted information. We will filter the data, we will handle the missing data. Like that, lot of process we will do in this data preparation part. So more than 80% of the time, we will be spending it on the data cleaning only. Okay, the more accurate the data is, that much accurate output we can expect from our model. Then choosing a model. So in the choosing the model, we will choose the algorithm for our data. Okay, we can choose any algorithm of our wish, or sometimes what we will do is we will take 2 3 algorithms and we will apply the data in those algorithms, and we will check which algorithm can give the maximum accuracy. Then we will finalize that particular algorithm for our model. Then we have to train. So once we have chosen the algorithm, we have to pass the data and we have to train our model. Once the training process has been completed, we have to evaluate the model. So we have to test it with some data. So what we will do is in the complete data, 80 to 90% of the data, we will pass it for the training purpose, and remaining 10 to 20% we will keep it separately for the evaluation, the testing purpose. At that time, we will pass only the input and we will check what output the model is giving and what is the actual output. We will compare and we will perform some, error testing, everything we will do. What is the accuracy score, everything we will check. Then we will come to a conclusion. Okay, for this model with this data set, it can able to give this much percentage of accuracy. Like that, we will try to come to a conclusion. Then parameter tuning. If suppose we are getting very less percentage of accuracy, so we have some parameters to tune, like we can change the values of some parameter, and then we can again we will perform the training process, evaluation process we will do, and we will check whether the percentage has been increased or decreased. Like that, we will check. If the percentage is increasing means we will finalize with that particular model. Okay, we will expect more than 95% if we are getting. Okay, depend upon the model, it can able to perform. Then finally, prediction part. In the prediction part, what we will do is we will not pass the testing data. We will not pass the training data. Instead, we will completely pass a new data, and then we will try to check whether it can able to predict the output or not. Whether we are getting the expected output or not, we will check in the prediction part. So these are all the 7 basic steps we will have in the machine learning. projects. So why we need to learn this machine learning concept is there will be a huge demand in the upcoming years for this machine learning part. Okay, not only in the machine learning, it starts from data analytics, data scientist, business analyst, machine learning architecture, like that. Various job roles, new job roles are getting into the picture, and there will be a huge demand as well as there will be a high package also given for those developers and then analysts. So now itself, if you are planning to make the machine learning as a career, you can start learning all this concept. And initially, as a fresher, you will be recruited as a data analyst. You will be dealing with some the tools and all we have seen, right? Tools, some Excel data cleaning part, those things you will deal. Then you will understand the scenario, like what type of requirement expected by the client. Okay, how to satisfy the requirement, like this so many stages it will go. Okay, from business analytics it will go to data analytics, then it will go to the data scientist, then data collection part is there, cleaning part is there. Likewise, a big process will be there, and all this comes under the data science. Okay, so that is why we are giving a common name as data science. Inside the data science only, we are having the AI, ML, even deep learning also, a subset of machine learning only. Let us see what are all the applications of machine learning. So machine learning is not only used for computer science field alone. So various fields they are trying to implement the artificial intelligence concept to increase the productivity and then the accuracy. So first we can use it in disease detection and the classification. So if you are passing the test report, scan report, everything you are passing into the machine means it will analyze all the data and it will return, okay, what disease you are having, in what stage you are, okay, what type of precautions you have to take. Okay, if you are not taking means what type of consequence it will you have to face. So those things can be directed by a machine. Then social media. So everyone is using a social media account, right? Either it can be an Instagram, YouTube, Twitter, anything. So there it will perform the user pattern analysis. Okay, what type of videos you are watching frequently, which type of video you like, which type of videos you dislike. So everything what it will do is the algorithm will try to understand and similar kind of videos or recommendation it will provide it to you. Okay, some suggestions also it will give. In YouTube you might have realized it. YouTube also, in Instagram also. In Instagram if you are liking some reels, okay, continuously you are watching some reels means it will understand, okay, this particular person likes this related reels. So next time when you open the Instagram means you will be frequently getting the similar related reels, right? So those things are happening because of this user pattern analysis only. Then in the automated cars, we are having the pedestrian detection is there, lane detection is there, and then road sign detection is there, traffic sign detection. Likewise, various directions are there in the autonomous vehicle project. Then in the search engine, if you come for the search engine, means whenever you are typing some text, automatically it will give you the suggestion. It will try to complete the text. Even if you are giving a wrong spelling, also it will try to find the correct spelling and it will give you the result. So all this can be done in the search engine part. So here also again the AI only is taking place. Okay, based on the ranking method, web crawling method. Okay, it will provide you some suggestion, analysis, and then prediction. Okay, what you are trying to type, what you are trying to search for. So those things can be done. So these are all the some of the application. In real time, there are so many more applications are there. So these are all some of the commonly used application in various fields. Okay, so let us see the supervised learning in detail. So as we have already seen, supervised learning can be further classified into classification based, or it can be an regression based. So the main purpose of the classification is to classify the distinct variable, and the outputs will be in the form of classes. Some of the example are cat and dog classification, pen and mobile classification, like that. Two classification we can have, or we can also have more than two classifications as well. So we have already seen the 7 steps, right? So we will see that one by one. First is gathering the data, then data preparation is there. So we are going to see what are all the algorithms we are going to use one by one. So based on we can use it for binary classification, as we have seen a cat, dog, pen and paper, like that we can create. Or multi-class classification we are having, and then we are having multi-label classification. So multi-class and multi-label, how it differs is, in multi-label, in single frame, okay, what and all object it can able to direct. So each and every object it will frame it, and it will give the label of that particular object. Then we call it as multi-label. And then imbalanced classification is, in that two classification is there, means it will be more focused on one class instead of another class. Okay, the data set itself will be an unbalanced data. So those we call it as imbalanced classification. The first algorithm we are going to see is logistic regression. So here it uses one or more independent variable as x-axis. Okay, we are having x-axis and y-axis, right? So in the x-axis, we will be plotting the independent variable, and in the y-axis, we will be plotting the dependent variable. So based on that only, we will get the output graph. So in the logistic regression, it will form a S curve. Okay, it looks like a S shape. Here the data either will be of 0, or it will be of 1. Okay, up to some certain point, the values will be 0. After that, once it has started raising, means the values will be in the top only. It will be like 1. So we can use it for binary classification. So we can able to easily categorize. Okay, one category of data will be in the lower point, and another category will be of the higher points. Okay. Sometimes there is some possibility that we will get points in the middle region also. Okay, instead of getting 1 and 0, we can get some middle values also. So in that scenario, what our logistic regression will do is, it will try to find the mean value. Okay, it will find the mean value, and whatever points are coming above the mean value. Okay, for example, 1 0 mean value, if I am taking it as 0.5, just for our assumption. Okay, and I am taking one values as class A and 0 values as class B. So whatever value are more than 0.5, then it will group them as class A. Okay, this point, any point is coming more than 0.5, it will convert them into class A. Similarly, whichever points are coming below 0.5, it will consider them as the class B data. Then we are having K nearest neighbor algorithm. So how this algorithm will work is, first we will plot all the values in our graph. Then we will know, okay, in the color, based on the color difference, we can able to understand. Okay, so these dots, white color dots and all, will come under one class. Okay, for our assumption, I will take it as class A. And then this orange colored dots and all, I will take it as class B. Then what it will do is it will try to plot one new point in our existing graph. So that new point is represented with the blue color. Then as per the name itself, K nearest neighbor. So what it will do is it will try to find the nearest point from the new points. Okay, here K means number of how many number of nearest neighbor or nearest point you are going to take. Here mostly we will give the K value in the odd number only. Why? Because if I am giving even number, if I am giving 6 nearest neighbor, I want to take means 6, 2, 4, like that. If I am giving means, there is more possibility that we can get 3 point as class A and 3 points of class B. There is possibilities there. If we are getting like this means we cannot make one decision. So to avoid this conflict, we will go for odd number. So if I'm taking 7, 3, 5 like that, if I'm taking means there is high possibility that any one class will get more points than the another class. So we can easily come to a conclusion this particular new point belongs to which class. So this is the reason we take the K value as odd number value. Then this points how it has been taken is based on the distance. Okay, nearest distance points only we will take. So in this example, K value we have given it as 3. So it is taking the nearest 3 value from the new point, and we can clearly say that 2 points are from the orange color and 1 point is from the white color. So we will consider this new point also as class B category only. Okay, if we have got 2 white dots and 1 orange dot means then we will say it is belongs to the class A category. Here, how it will calculate the distance? We are having two different methods for that also. Either we can use the equivalent distance method or we can use the Manhattan distance method. So how this Euclidean distance method will work is simply from my dot new dot, I will just try to draw a line and whichever line is having the smallest distance. Even I can draw a line to here, okay, here. Okay, whatever point I can able to connect, I will draw. But in this, which 3 dot is having the less distance when compared to other dots? So those 3 dots alone I will take. So remaining dots I will take. If I've given 5 means again 5 nearest points I will try to take. In this case, I'm taking the 3 and out of this 3, 2 are from orange. So I will consider this new value also belongs to the orange class. This is Euclidean distance method. But if I'm going for the Manhattan distance method, okay, every time this Euclidean distance will not be the sufficient method. For example, Google Map is there. Okay, in Google Map, you are standing in one particular location and you want to reach a nearby restaurant or any place you want to visit. Okay. In the map, if it is showing the distance like this, whether it is possible for us to travel. No, right. We are not going to fly. Okay. We have to use the road. Okay. So our m- map should say, okay, you have to take right, you have to take left. Like that map has to say some distance. Then only it is the correct method, right? So for that only, we will go for this Manhattan distance method. Okay. So why we have given this Manhattan distance, like Manhattan name is, there is one city called Manhattan. Okay. In that, this is how they have designed the city. Okay. Like square boxes, they have created the city and they have created all the buildings. Okay, suppose you are in this particular location, okay, any location in this particular city, and you want to reach this location means what are all the possible scenarios are there? So that we will try to find. Okay, we can either go this way or this way. Likewise, various ways possible we will take, and which is will take the less time to reach the destination. So here, based on the box, if you are taking means in this way, one, two, three, four. So four boxes they have to travel. If this box, if I'm taking means again four boxes. If I'm taking different path, four or five boxes it is coming means whichever is having the least boxes. Okay, least distance it is having. Okay, even though if it is having four boxes there, but it is taking 2 kilometer to reach the location. But here it is taking only 1.6 kilometer. Then obviously we will go for the less distance. Okay, so like this we are coming to a conclusion, right? So this distance method only we call it as Manhattan distance method. Okay, based on the data points, we will decide whether we can to go for the Euclidean distance or we have to go for the Manhattan distance. Then we are having the support vector mission algorithm. So in the support vector machine, what they will do is they will use the separating hyperlink. Okay, two classes are there. Dog class is there, cat class is there. So they will separate it based on the hyperline and they will draw some margin from that hyperline. Okay, centrally I'm dividing and I'm giving some margin. Okay, the margin length. And with the help of the margin length, in the margin length, okay, what and all points it is touching. Okay, those points we call it as support vectors. Okay, so based on this support vector only, it will able to understand okay which class is having this direction and which class we are having in that opposite direction. So whenever a new point is coming into the picture, based on this margin and the support vector, we will decide okay this new point belongs to which class, whether it belongs to class A or it belongs to class B. Then we are having the decision tree method. So in the decision tree, based on the user response, okay, the machine will ask one question. Based on the user response, it will ask another question like that. It will ask some sequence of question until it comes to a final conclusion. Okay. So based on the outputs given by the user, it will generate one final conclusion. So in this scenario, if you see means first it is asking outlook. Okay, it is asking to outlook, and we have three options. Either we can say it is sunny, or it is overcast, or we can say rain. Okay, if I am saying overcast means it will say yes, you are allowed to go out. But if I am saying sunny means it will ask another question whether it is humidity high or normal. If I am saying humidity is high means then it will say no, you are not allowed to go out. If I am saying humidity is normal means okay, you are allowed to go out. Similarly, if I am saying rain, then it will ask another question like whether it is wind is strong or weak. If I say strong means no, you are not allowed. If I say weak means okay, you are allowed to go out. So like this, it will change the decision based on the user input. So that is why we are calling this as an decision tree method. Okay, so it uses if then rule to classify the points. So finally, we will have either one answer only. Either yes, you are allowed to go or no, you are not allowed to go. Okay, we can use it for the classification also. Okay, either it is a dog or it is a cat. Like that, we can come to a conclusion. Then we are having the random forest method. So this random forest is not like a separate algorithm. So this algorithm we call it as ensemble learning. So what this ensemble learning will do is it will take one existing algorithm and it will repeat it multiple times in different format and it will collect all the output and finally it will give the result based on the majority voting or the average basis. Okay, so if we are dealing with a classification based problem, okay, it will run the different scenarios. So it will take the data set and it will run the all possible scenarios, and it will collect the output of all these scenarios. And if it is a classification based, means it will check what is the majority voting, like which result we have got multiple times, majority of times which output we have got. Then that output it will return it as the final result. Okay, that is for classification. If you are going for the regression, means each tree will give the output, different numbers it will give, right? So it will collect all the numbers and it will find the average of that number and it will return it as a final output. Okay, so this is what this decision forest method will do. Then we are having the Navy bias algorithm. So we have learned about the probability concept, right? So using that, we will try to know the probability of event A, which can occur by knowing the event B has already occurred. Okay, so these Navy bias algorithm, we can use it for the spam filtering. Okay, other similar features, we can use this Navy bias algorithm. Then neural network. So this neural network concept, we will mostly use it in the deep learning concept. In the neural network, we will have three layers. Okay, why we are calling it as neural network is like how in the human brain we are having neurons. Similarly, here also we will have the neuron which will be interconnected. So we can able to see in the image. It is showing like a mesh like structure, right? So one neuron will be connected to the another neuron. So output of one neuron will be passed as the input of the another neuron. So in here we are having three layers. First layer is the input layer where the input will be passed by the user, and last layer is going to be our output layer. Okay, final output it has generated. In the middle we will have the hidden layers. So in the hidden layer only it will try to find the pattern. It will increase the weights and it will check. Okay, we can have multiple hidden layers as we want. And each neuron will be connected with each other, and final output we will get it as in the output layer. Okay, so mostly we will use this neural network concept and all in the deep learning part for image classification. Actual image, if you are taking means image classification, video, voice, natural language processing. So for this thing, we will use this neural network concept. Then we are having the gradient descent method. So for the huge data set, we can use this gradient descent method. So in that, what it will do is it will randomly pick some sample data for the training. Okay, randomly some set of data it will take and it will train our model, and then it will try to find the error. Okay, how much error it is getting. Once it has found the error rate, it will try to adjust the weights. Okay, every time it will add some weight and it will change the data. Okay, until it gets the actual output. For example, if I want to get output as 100, okay, just assumption some values there, I have to get the value as 100. I'm giving some weights to my model, and for that weight it is giving 85, and I'm trying to increase the weight. So when I'm increasing the weight, the values are also getting increased. Then accordingly, our output value also will change. The error rate also will start reducing. So this will be, processed in a loop until it reaches the actual value. Okay, like this, it will take it in random data and it will perform this particular operation. So once we have chosen the algorithm, we have to train our model. Then after training, we have to evaluate. So for evaluation also, we are having various methods. Okay. holdout method. So what it will do is it will divide the data into 80% for training and 20% for testing, and uses the test data to predict the output. Okay, so we can use the cross validation method. So in the cross validation method, what we can do is this 20% of data we are taking, right? So that instead of taking it from one specific position, like taking it in the last or taking it in the uh, beginning, what we will do is we will take it equal size from different location. Okay, so randomly we will partition into k subset of same size. Then we will use the same subset for the testing purpose. So in the drawing, we can able to see from starting, we have taken from the last, then slowly we have moved to the center, then to the beginning of the data set. So randomly, we will take the uh, testing data set from our actual data set. So that is what the cross validation will do. And in the ROC method, we will try to find the relationship between the TP and FP, which is nothing but true positive and the false positive rate. So the area under the ROC curve shows the model accuracy. Okay, what accuracy we are having. So we are having different lines, right? In that perfect classifier, that violet color, we are calling it as the perfect classifier. And in the red uh, dashed lines, we are calling it as the random classifier. Okay, slowly it will make the curve and it will get the perfect classifier. Okay, in the x-axis we have give the false positive rate, and in the y-axis we will give the true positive rate. Then we can find the confusion matrix. So another name for this classification report is confusion matrix. Here we will try to find true positive, false positive, false negative, true negative. So what it means is, suppose you are taking a cancer data set. Okay, true positive means actually 100 members are having cancer. Okay, and our model also predicted 100 or anything. Okay, this we call it as true positive. So, uh, cancer is there in the actual data, and the predicted data also is saying cancer is there. Then we can call that as a true positive. False positive means the person is not having the cancer. Okay, no cancer is there. But our data is saying the person is having cancer means then we can call it as false positive. Then false negative means the person is having cancer, but our prediction is saying the person is not having the cancer. Then we can call it as false negative. Then the person is not having the cancer and our data, our model is also saying the person is not having cancer means then that is true negative. Okay. So like this, we will find the data and we will make sure that the false positive and false negative, we will get very less value or zero. If it is zero means best output we can say. If some values are there means we will try to improvise it, because false positive is like type 1 case. The person is not having the cancer and we are saying he is having cancer. So when we start the treatment, we can able to find it. Okay, the person is not having the cancer. But this type 2 is a little bit risky because the person is having the cancer. But we are saying the person is not having the cancer. In that case, what it will happen is the person may get affected by that disease, right? If corona is there, the person is having corona, but we are saying the person is not having corona. What type of impact it will create? Just imagine. Okay, he will go out, he will think that he is not having the corona and he will start spreading it to other people. So because of him, the cases will get increased. So we should be careful in both the cases. So for different algorithms, we will use different evaluation method. Then parameter tuning. So once we have evaluated, if you are not getting the accuracy as we expected, we will just try to perform some tuning method. Then finally, we will predict the data. So the purpose of the regression is to predicting the continuous values. Okay, so output will be in the form of real numbers. So example we can say is house price prediction, stock prediction, gold price prediction, Bitcoin prediction, like that. Various predictions we can use this regression type. Okay, steps again steps are going to be same for this regression one also. Only thing is going to change is the algorithm. The choice of algorithm is going to change. So here, as we have seen, linear regression is there, logistic regression is there, and then polynomial regression is there. So in the linear regression, the output we get like a linear line. Okay, line we will get a slope, we can say. So here I have taken x-axis and then y-axis data. Okay, and I'm plotting it in a graph. All the green point represent the x and y-axis points. Then I will find the mean value for the x and then the y. Then what I will do is I will try to subtract the mean value with all the values in my x. Similarly for the y also I will do the same. So x minus x means I will perform and I will store it in one new column, and y minus y mean I will find and I will store it in another new column. Then what I will do is x minus x mean I have found, right? For that I will find the square. Okay, and I will add all the values and I will find the sum for the x minus x mean square. Then what I will do is I have found these two values, right? I will multiply the x minus x mean value with y minus y mean value. Then I will create another one new column, and those values also I will add and I will sum the value. Okay, the formula we know is y equal to mx plus c. Here c is constant. So constant is equal to 2.4 we are taking. To find the m, this is the formula. So x minus x mean into y minus y mean divided by x minus x mean the whole square. So we have found the sum value. So 4 by 10, we will get 0.4. So m is equal to 0.4. If I apply it into my formula, y is equal to 0.4x plus 2.4. Okay, if I perform this calculation means I will get this slope value. This red color dot represent the point of 3 comma 3.6. So that is what I have highlighted in the red color. Okay, and if I draw straight line means you can able to see in x it will touch the 3 and in y it will touch the 3.6. And I am trying to draw a slope which can touch maximum points. Okay, so here we are using the linear, so it cannot touch all the points. So the data which we are having is increasing when the x value is increasing as well as the y value is also increasing, means in those scenarios only we can able to use this linear regression method. So the variables which we are going to use will be in a continuous dependent variable, and the accuracy we will find based on the measure by loss, r squared, and so on. And the output will be the value of the output variable. So logistic regression we have already seen, right? So it will be an S-shaped output we will get. And here the variable is going to be categorical dependent variable. And to find the accuracy, we will use the measured by accuracy is there, precision is there, recall, F1 score, confusion matrix, so on. Then output will be in the form of true or false, like yes or no, this or that, like that only we will get the output. Then we are having the polynomial regression. So in the polynomial regression, so where and all we cannot use the linear regression. Okay, if we are using the linear regression for this particular data, we will miss most of the points. So to avoid that, we will go for the polynomial regression where we can slightly bend the curve. Okay, the line we can bend and we can make it as a curve to touch maximum point as possible. So for that only we will perform the data visualization before choosing the algorithm. So in the data visualization itself, we can get some insight about the data. So forgot about this line, green line. Just by seeing the data itself, we can able to see there is some curve in the data. So after that curve, the data are just getting increased. When X value increase, Y value is also increasing along with that. So for this, if I'm using the linear curve, linear regression means I will miss all these bottom points. So to avoid that, I will go for the polynomial regression method. So I can make a curve in my output to touch the maximum values. Then only the accuracy, everything will get increased. So remaining steps are going to be same only. Okay, training part, evaluation, and then parameter tuning and the prediction part. Okay, so let us take one project and we will see how to execute it, what algorithm to use, how we are evaluating it in detail. Okay, we have taken the energy meter using machine learning. Okay, energy meter readings we are taking and then we are giving some different classes. First, we will see the data set. So the data set we are having is energy meter.csv. In that values is given and then the classes are given. And there is no heading for our values. Okay. And from the Panda library, I have importing only the read underscore CSV. I don't need any other method. So I'm taking only the read underscore CSV alone. Okay. So I'm giving for pandas import read underscore CSV. Then I'm giving the file name as energymeter.csv. Then names for my column. Okay, I'm giving it as voltage, current, power, and then class. Then in the data set, I'm reading the CSV file by passing the file name and the names is equal to this names list I'm passing. Okay. Then I am summarizing the data set. I'm trying to find the shape. Okay, I'm trying to see first to five column of my data set. And then describe method, we will know, right? We will get the count, standard deviation, all the details we will get. And finally, I'm grouping based on the class and then I'm finding the size. So what this will do is class we have given for the last column, right? So we will have three or four different classes. So it will group according to the class and then size means how many rows having that particular class, like that it will give the output. So here you can able to see class. We are having medium, no load, normal, risk, like that. Four classes there. In each class, we are having 100 data or the record we can say. So totally we are having 400 records, which is 400 row, and then four columns we are having. Okay, so this is the first five rows of our data set along with the column name which we have given. Then if I use the describe method, it will return the count, mean, standard deviation, minimum, 25%, 15%, 75%, and then the maximum value. It will perform for only the numerical columns, not for the string. Then data visualization. We are trying to visualize the data. For that, I'm using the matplotlib here. Okay. So here I'm trying to create a bar chart. Okay, in that I have given some sub classes and for each subplot I have given some title also. Okay, bar plot, histogram plot, and then scatter plot. So this is how the bar plot will look. Okay, for power and voltage, current is there, and here voltage separate histogram chart, current separate histogram chart, and then power separate histogram chart, and then the scatter plot. Okay, it will compare all the columns with another column. See here voltage is there means voltage will be compared with power, current and its own voltage. Again current will be compared with power, current, voltage. Power with power. current and then the voltage. So likewise, I'm comparing and I'm creating the scatter plot. Then evaluating various machine learning algorithms. So what I'm doing is I'm taking 4, 5 algorithms and I'm going to pass all the algorithm with my data set. Whatever data set I'm having, I'm going to pass it and I'm going to check which algorithm is going to give me the maximum accuracy. Okay, I have taken this logistic regression. I have taken a decision tree classification. I have taken a k nearest classification, like that. Various classifications I have taken. And then from this psychic learn model. Okay, this is also another library, very important library for machine learning. So from the scikit-learn only, we will take all the algorithms as well as the model selection. In the model selection, I am taking the trains, test, split, cross validation, k-fold method, everything I am importing into my program. Then in data set, we are having 4 columns, right? In the 4 column, first 3 columns is the independent variable and the last column is the dependent variable, which is going to be by our y, the output part. So what I have done is array of first 3 column, I am placing it in x and last column I am placing it in my y. Then I am creating a 4 variable, okay, x train, x validation, y train, and then y validation using the train test split method. Here in the parameter I have given test size equal to 0.20, which is 20%. If I want to give only 10% means I just have to change it to 0.10. Okay, random state, shuffle, everything I have given it as true. Okay, let me run this. Now, so different models are there, right? I'm going to store all the model values in one list. Okay, list I have created models. In that, I'm appending all the algorithms. Okay. Then I have to store all the result in one list. Okay, that is why I'm creating one result list. I'm creating empty list, names. Okay, and then res. I'm using one for loop. In that for loop, it will take one algorithm and it will upload all the data set into that particular algorithm and it will perform the testing. It will get the result and it will append the result in that particular result list. Okay, like that it will perform for all the models. Then finally, I am creating one plot. In that plot, I am passing all the values. So here you can clearly see that, okay, logistic regression, right? That is the first algorithm we have used, right? Logistic regression is having the maximum accuracy, so 99.68. Even logistic regression as well as the another algorithm, linear discrimination analysis, also having the highest accuracy rate when compared to other. See, all the algorithms are having more than 99% only, but in that also logistic regression is having the more accuracy rate. So we can say that this logistic regression algorithm, we can use it for our data. So in this way only we will try to find okay, which algorithm will be the best fit for our data set. So we can also try with, okay, I don't want 20% data. I only need 10% data for testing. Then we have to again rerun the all the columns and we have to check whether any change in the result or not. See, when I'm giving 10 percentage to testing part, the output is changing. Now, the logistic regression is having 99.72. As expected, it is having the higher value. But for the second algorithm, it is only 99.4%. Okay, which is equal to the k nearest neighbor algorithm. So likewise, the values will change. So we have to change the parameter and we have to find the best algorithm. So even after changing the test value, I'm getting the linear regression as the maximum. So I will conclude with this. Okay, this logistic regression is the best fit for our model.